So this one was a lot of rates. I did my usual, I always just completely dissect the problem before I start so I can wrap my brain around what's happening. So I've got water going into a drain pipe. I've got an equation for that. So that is a rate, which is already a derivative. Keep that in mind. I'm going from 0 to 8 hours. It's partially blocked, allowing it to drain from the other end at this rate. So that's my amount out. Again, another rate, so another derivative. And then I have an initial amount here, and I even wrote that to the side because I didn't want to forget that initial amount there. So just some notes so I knew what was important. So it's like, and I already knew as soon as I read the problem, I was like, I already know what's going to happen, right? They're going to ask me how much has been there. They're going to ask me the rate that it's coming in. Is it flowing in or out faster? What's going on? So you kind of can get a lot from the first part of the problem. All right, here we go, part A. Part A says, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? This is only asking me to reference R. And again, this is a calculator, so I put this in Y1, set up my integral, and just use the calculator to find out. Make sure you are in radians and not in degrees, because this is a trig function and that will mess you up. So this one was 2 points, actually. You got 1 point for the integrand, and you got 1 point for the answer. And you could have actually just put R of t here. You didn't have to write out that whole equation. So if you did integral from 0 to 8 of R of t dt, you put 8 in what? Plug it in what? In R? That's your rate, remember. Not the amount. No, because that's, if you plugged 8 in, that's saying how fast it's coming in at hour 8. Because if you look, it tells you in cubic feet per hour. All right, part B. It took me a minute to wrap my brain around part B. Is the amount of water in the pipe increasing or decreasing at time t equals 3 hours, and give a reason for your answer? So you can see I kind of started thinking through it. The total amount in the pipe is going to be my initial amount plus the amount in minus the amount out. But that's not what they were asking me. They're asking me about the rate, right? So I went back. The rate in minus the rate out will give me the rate that water is accumulating in there, right? Whether it's if it's positive, then I'm gaining more water than I'm letting out. And if it's negative, then I'm letting out more water than I'm getting in. And so I don't even have to take that initial amount into account right here. I just have to think, well, what is the rate at that time? Because they asked me at time 3. So I subtracted the 2. And whenever I did, I didn't even find what that was. I know that's a negative one.
Exactly what I did.
What I did? I think that would work because did you consider R of 3 and B of 3? Like, where was the graph at time 3? Yeah. And you said the rate is decreasing, therefore the amount of water is decreasing? I would say that's your full 2 points. So you got 1 point for considering R of 3 and D of 3. Whether you subtracted them, whether you did whatever, if you looked at, you knew you needed to look at R of 3 and D of 3. You didn't know what to do with them, but you knew at that point you needed to use the rate. That was 1 point, and then you got 1 point for your answer with your reasoning. I said the rate is decreasing, therefore the amount of water is decreasing at time t equals 3. They said since R of 3 is less than D of 3, which is kind of what you did, Robert, the amount of water in the pipe is decreasing at time 3 hours. So as long as you explained it being less than the rate. Are you in radians or degrees? If you were in degrees, it gave you the complete wrong answer. But you didn't get D of 3 being 5.4. Yay, for X. I wonder if maybe you didn't square the T or you divide. Something happened with the way you inputted it here. This is not a trig function. So maybe you typed one of them in, or maybe you typed one in wrong and one in right. I don't know. All right, I'm in Y1. I saved all my equations so y'all could see them. Here's my Y1. So if I go into table, okay, at, what is it, at 3? There must have been a little something off with the equation. All right. I would still say you got 1 out of 2 points there because you need to look at 3. You see what I'm saying? Because you considered R3. That's okay. You just missed the answer for it. Because it just says considers R3. That was 2. So 2 and 2. All right. Number or letter C. At what time is the amount of water in the pipe at a minimum? This one was more heavy laden work-wise than what I really anticipated. So you need maxes and mins here, right? And I'm doing maxes and mins. I'm finding zeros of the derivative. Well, the derivative are the two rates subtracted because I'm talking about the amount of water in the pipe. So I have to take the amount in minus the amount out. So what I did was I set up, let me just show you. In Y3, I set up Y1 minus Y2 so that was a function on its own. Okay, so that makes it a little easier for me to reference. And so then what I did was I graphed Y3 and I found the zeros between 0 and 8, which it just happened to be 1, which is 3.2717. It's okay. Okay, so when you're in this part, if you come over, see the equal sign? If you click on it, and it's highlighted, it's on. If you click on it, and it's not highlighted, then it's off. So right now, I could turn them all off except that one. So now that one's on, and I can do like a zoom stick or whatever I want to zoom on it. And it'll be just that graph. Oh my goodness, no, yeah. Just turn them on and off. I do that a lot throughout the test, and it saves a lot of time. And then you've still got it there also if you need to come back to it. Like if you run out of time and you want to come back to it, you've got time. I had another one on. But anyway, all right. Found those zeros, but here's what you had to do because it said when was it at a minimum. Well, remember I didn't start with 0, right? I started with 30 in there. So this is one of those extreme value things where you got to test every single one. You got to test the endpoints and you got to test your zeros in order to find the minimum. So a lot of your points are coming here. Did you check at 0? Did you check at 3.2717? And did you check at 8 for the amount of water? And that amount of water is your integral. Remember, I've already got it in my calculator, right? I've got the Y1. I can integrate from here. So I can say math. Okay. Because they asked for justification, you would have to justify how you knew it. Because you don't know, technically, yes, this has got to be a minimum. Okay, let's see. Did you consider R of t minus b of t equals 0? So that's their first point. They give you a point for doing R of t minus B of t equals 0. So yes, yeah. And then you get 1 point for the answer, and then the justification is 1. Let me show you their justification, and then we'll talk about it. All right, so their justification is a table of values here. That's literally all. But I think if you put it in words, I think since there's only 1 0 in this interval, and it goes from decreasing to increasing, there's no way it would have to be a minimum. So I would probably give you that if I was reading it. If there were multiple ones, you know what I'm saying? Yeah. But make sure you do say that at that particular time. You know what I'm saying? Make sure you use all your. That was 3 points. So it's 1 for R of t minus B of t equals 0, which I would say saying R of t equals B of t is the same thing. 1 point for the answer and 1 point for the justification. Remember, these are real people reading your. I mean, it takes them a long time to grade these, and they all sit at tables in this big room, and they compare and they talk, and so it's yeah. I would probably say that the intersection would give you the point for the R of t minus B of t. That wouldn't really be justification for the minimum because you would need to say from decreasing to increasing or testing the values or something like that for the justification. But I would give you the point for that part. For that. All right, part B. Y'all know these are my favorite, right? But do not solve an equation involving one or more integrals. It gives the time W in the pipe will begin to overflow, and it says it can hold up to 50 feet. So I've been doing this the whole time. So I start with 30 and I add in. Well, the amount of water in the pipe is how much comes in minus how much comes out from 0 to, they said W. They said use an arbitrary time W. So I use W. Set it equal to 0. That was 2 points for that one little equation. 1 point for the integral and 1 point for the equation. So even if you didn't get the equation, but you need to use this integral, you still got a point. This is what? Yes, 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 yes. I would say 1 out of the 2. Yeah. Okay, y'all ready for number 2? How many y'all get on number 1? That'll be good. We're doing better than we started out, though, right? We're not goose egging anything anymore, are we? What's what? 9. Everything's 9. Every entire FRQ is worth 9. But it just depends. So like this one for part A was 2, B was 2, C was 3, and C was 2. Yeah. All right. I really like number 2. I went ahead as soon as I started number 2. Calculate that intersection point. You know you're going to need it. You see 2 different regions. You see 2 different equations. Before I even dug into this problem, I put this in, and I've got a note here, Y4 and Y5, because I wanted to show y'all a couple things on the calculator. So I still have those first equations stored in my calculator. That's especially handy if you need to come back to something because you got bogged down time-wise and you want to come back to number 1. They're still in there. You don't have to take the time to retype them. Just turn them off and type these in Y4 and Y5 so you can. So I've got these 2 entered in. I went ahead and calculated this intersection point. I wrote that on here so I don't have to do that ever again. I know I'm going to need it. And so then I have everything. I also labeled. I noticed that the graphs were crossing over. I labeled which one would be on top and bottom each time so I did not get myself confused. You will get, I know that you'll look at it and you'll go, oh, that's easy, I can figure that out. But then you'll get flustered on the test and you'll start running short on time and it's better to have it there so you can look at it really quick and know. All right, so part A, find the sum of the areas of regions R and region S. So I've got 2 different regions there, and they flip-flop which one's on top. So I got to do top minus bottom for R. That's where I got G minus F. I'm going from 0 to that point of intersection, right? And then for part S, flip-flop, F minus G, top minus bottom. And I'm going from intersection to 2. On that one, and then from there it's strictly calculator, right? 0.9974 and 1.0069 to give you approximately 2.00. 1 point for this one was actually worth 4 points. 1 point for the limits. The limits meaning these values on your integrand because you calculated the intersection and you knew that's where you needed to divide it. 2 points for the 2 different integrands, but you had to get them both. So if you know it's G minus F and then F minus G, that's 2 points for both of those. The first point are the limits. So if you have 0 and 1.032 and 1.032 and 2, that's a point. Okay, so even if you got the integrands wrong, but you got the limits right, you got a point. And then you get 2 points, and it's not broke down 1 for each, it's 2 altogether for both of these integrands here. So knowing F minus G, or G minus F on this one and F minus G on that one. And that's 2 points. And then your answer itself is 1 point. Yeah, that's what I'm saying. Isn't that nice? That's why I say if you're running short on time, always take the time to write it. That one just for writing down the stuff. You didn't have it all as explanation. All right, part B says the area region S is a solid whose cross sections are perpendicular to the x-axis of squares. I'm not revolving. I don't see any revolution word in here, okay? So that's not my pi. This is just a cross section. So understand the difference. If it says revolve, that's when I'm talking about circles, right? But I'm not revolving. I'm just cross sections. Squares are the easiest. So the distance between, notice it just says region S. It's not both regions. It's just region S. So the area of just region S, if it's a square, it's going to be side squared. So f of x minus g of x squared. That's my area. So to find volume, I integrate area. So I integrate, and I'm going from that point of intersection to 2, and I'm squaring this. You are thinking revolution, because the area of a circle is pi r squared. So you have to do the area of the whole one and the area of the little whole one. And so you square each one of those and then subtract them. If you're thinking women's revolution, you always and I get confused with it, and that's why I write it. I always write the equation for the area, and then I integrate area. Well, so you got. Well, you might not have got any points on that one. Sorry. 2 points. This one was 3 points. 2 points for the integrand. 1 point for the answer. Those are 3 points. First, yeah. 2 points for the integrand and 1 point for the answer. See, usually C's the harder one. Usually they get harder as you go. This one happened to be the easiest one, I thought. If you read it, watch what you have to do. H is the vertical distance between the graphs of F and G. So I went ahead and said, okay. And we're still just in S. We're not even using R anymore. Well, the vertical distance is just F minus G. Do you agree? I wrote that equation first. I said, okay, well, H is F minus G. Then it said, find the rate at which H changes. Well, rate means, what's rate mean? Derivative. So find the derivative of H when X is 1.8. Well, if H is F minus G, then the derivative of H is derivative of F minus derivative of G. And then all I have to do is plug 1.8 in. I used my calculator and did inderiv here. It was. So for this one, you got a point for correctly considering H of X, knowing that you subtracted the 2. And then, actually, no, you didn't. You got a point for considering the derivative of H. I don't know really what that means. Let me show you what they have. Did I give yourself a point out of 2 at least? Because it says considers H prime. I would think, considering H prime, you would need to have H prime right. I would say. Yeah, I didn't even show you what I did. What you got? A derivative is a rate. So by taking the derivative of h, I found the rate that h is changing. Yeah. Yes. 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 You'd need to say dhdx since x is your independent variable there, but I would say yes. I used the calculator in deriv because I already had f. Remember, I've already got f plugged in my calculator. I've already got d plugged in my calculator. Okay. Negative 3.8117. All right, how'd y'all do on that one? All right. 3 was the one that y'all should have knocked out of the park because he's done them so much. I hope anyway. Johanna jogs along a straight path. Velocity given by differentiable function d of t. T is measured in minutes, b is measured in meters per minute, and in the table above I have the data. Use the data to estimate d prime of 16, that is if a rock. If they ask me to estimate a derivative from a table, I am just going to do a rock. And so that was a little, I think, 1 point. Yeah. 1 point there for the approximation of 5 meters per minute squared. This one did not specify, but do get in the habit of doing it because sometimes it's 1 point. Yeah. You did what? You left it like that? Yeah. I mean, they say if you leave it like that, then yeah. Part B. It was 3 points. Using correct units, explain the meaning of the definition of the definite interval of the absolute value. Yeah. That's the first part. So the absolute value of velocity, if I integrate that, remember that's my total distance traveled. They want it in, you got that? They want it in context. Absolute value of velocity on its own is speed, but the integral of the absolute value is total distance traveled. Make sure you describe it in context of the problem because it says explain in context of the problem. So it's the total distance. I probably should have said that Johanna jogged during the first 40 minutes. That was 1 point for that explanation. Then you had to do a right Riemann sum using 4 intervals. And remember, this is absolute value. So as you go through, as I looked up there, I got 12 times 200. The only one that changed there was that that 220 becomes positive because I need to get positive. I stopped there because I didn't have a calculator, but I think it comes to come out to 7,600 meters if you got a. So it was 1 point for the right Riemann sum and 1 point for the approximation. And so I don't really understand the difference there. Yeah. The answer. The answer. But you can leave it the way, yeah. So 1 point for the explanation, 1 point for the right Riemann sum, and 1 point for the answer. Showing that you did this. You have, anytime they ask for a Riemann sum or a trap rule or anything like that, you need to show. Yeah. Sorry. It's, it's right beside it. I'm gonna say probably no. They wouldn't do that. It's labeled wrong. Yeah, they'll be on different pages. But I will say, if you have anything on there, make sure if you don't want them to grade it, that you scratch it out. They won't grade anything scratched out. If you scratch out right work, they also will not take it. So if you, no, I'm saying like don't like not know how to work something and work it two different ways and lightly scratch out one way and go, well, maybe they'll be nice and see that I knew how, because they won't grade it. I think they would probably not give you credit if you did it. I'm thinking. Let me look that up and see. Let me don't quote me on it. Let me look up that. Don't know that anybody's ever asked me that. I'll look it up. I'll find out. I feel like I've read about that somewhere and I just can't remember exactly what it said. So don't quote me. I'll look it up. All right, part C. I thought C was really easy. C gave you Bob riding his bicycle, and then it gave you the velocity, it asked you for the acceleration. It was a straight derivative, and then you plugged in 5. That's all it was. So 1 point for b prime of t, which was the acceleration. So 3t squared minus 12t gave you a point, and then 1 point for the answer, which was 15 meters per minute squared. It doesn't say this time, but yeah, it doesn't say this time. Part D was, okay, those two. Part D was 3 points, but I think it was more because it was so involved and not necessarily as much as how hard it was. But it was average velocity. Remember, average velocity is like average value. That's the 1 over b minus a, and then you go from a to b. And so you've got to do an antiderivative here and then divide everything by 10 at the end. I ended up getting 350 meters per minute. So you got 1 point for setting up the integral correctly here. You got 1 point for correctly finding the antiderivative, and then a point for the answer. You don't remember doing this? Anytime it asks you for average value of something is always 1 over b minus a times the integral from a to b. What? I had everything. I had it. I would probably give you 2 out of 3 for that one then. Because because you had the integral correctly, you got the antiderivative correctly, you just didn't get the answer because it's technically not part of the integral. I would say that's what I would say, based on how they have the scoring there. Stella and Joyce, we missed y'all today. Yeah, we did.